Hello, my friend. Finally, I make another video. It's been a long time, but I was in Tuscany. I was back to my home, and I have to tell you, my friend, how beautiful that place is. So I suggest you to close this video, press the dislike button, and just go, my friend. Amazing. Anyway, if you decide to stay, today we are talking about declaration. This is paragraph 2.4 of the Carnegie and Ritchie book. Okay. Seems like a pretty simple argument, but believe me, there is something that needs to be understood. Okay, let's go on. So the thing that, in my opinion, needs to be understood is the difference between four keywords, which are namely keywords, four ideas: declaration, definition, initialization, and assignment. These are four ideas that you will understand immediately. So when we declare a variable, what is really going on inside our machine? Well, when we declare a variable, we are basically telling our compiler, hey, there's going to be a variable in my program. So just keep in mind that I want, for example, an integer, and this integer is going to have the name and b, okay? So here I think that a very, very good analogy is the one with the restaurant and with a waiter, right? Because when we declare a variable, we are essentially taking a reservation. It's like we are telling to our compiler, hey, keep in mind that tonight an integer called nb is gonna come at dinner in our restaurant. Okay, that's basically a very good analogy in my opinion. So what is going to happen when we say, for example, int nb? Well, our compiler is gonna take the reservation. It's gonna write in a very fancy data structure, which is called a symbol table. So it's really a good mnemonic for this analogy. The name of the variable, the type of the variable, and other data, but essentially the type and the name is the thing that is really important. So it's going to say, okay, so tonight is going to come to our program party this integer nb. Okay, perfect. I'm going to sign in my symbol table and we are okay. Thank you very much. So when I write int nb, I'm making a declaration, I'm making a reservation. Keep in mind this idea, and it's going to be very simple to understand everything. On the contrary, there is another idea, which is definition. So what is the difference between definition and declaration? It seems the same thing, right? It is the same thing, actually. But I'm going to explain you the details now. You know very well that the devil is on the details, and now you will understand why. So when we define a variable, it's like we are going into the actual restaurant. It's like the integer client is going inside the restaurant, is going inside the RAM, right? Our restaurant is the RAM. So when we define a variable, there are actual 4 bytes that are allocated. It's like the client is come, and now we give his paste, which was reserved, right? That's the idea. So here I wrote, defining a variable is like actually going in the restaurant and sitting in your reserved tables. I think that this is a very good analogy. So you have the declaration, the reservation, you call the restaurant, hey, tonight I'm gonna come. And the definition is when you go to the actual restaurant and you take your reserved place, okay? So now you understand that there is a clear difference between declaring a variable and defining a variable. But in practice, which is the thing we care, the only thing we care, right? We don't really care about theory, we want the practice. Well, my friend, in practice, when you declare a variable, when you write int nb, there is also the definition of the variable. When you write int nb, you are actually declaring the variable and also defining. So actually, you are already in the restaurant, okay? When you write int nb, it's like to physically go into the restaurant and ask for tables, and the waiter is immediately giving you the place, okay? Because it is available. Declaration and definition happens simultaneously, but not always, not always. But here we wrote, in general, if you declare a variable in C without using extern, which is a special keyword that by now I think you really don't need to understand. It's like a niche thing, but you need to know that you can do this stuff, okay? So without using extern, it is both declared and defined at the same time. So when you write int nb, you are declaring and defining a variable. Cool, easy peasy, we don't want to think about anything else. If you want to further your knowledge, your understanding of this point, you can watch this video, which is difference between definition and declaration, and you get this one, which is very well done. Declaration versus definition of variables and functions, but you can watch this one of variables. And by the way, this channel, which is Code Vault, is very well done. I really like it, and highly suggest to you, given that you want to learn C. Well, I'm learning C thanks to this dude as well, so I highly suggest you to watch. And here you will understand what is the core difference between declaration and definition. I just explained to you, but it's giving you a different twist, and it's always a good idea to listen to other people. So, coming back to us, keep in mind that when you write int nb, you're just declaring and defining a variable. Cool. Now another idea, which is the one of assignment. Well, what is assignment, my friend? You know very well this is super trivial. It's just giving a specific value to a specific variable. Here I wrote, assigning a value to a variable is like ordering the food you want to eat. It has to be the type of your reservation. This is the core idea, right, of the type. If you reserve for tables for a type ints or for a vegan, you have to order vegan food, right? You cannot order meat or something. This is a stupid analogy, but makes the point. If you reserve for bytes for an integer data type, you cannot put inside a string or, I don't know, a float and so forth. You need to give the value which is related to the type of the client, right? You understand me? So in this case, I have my variable nb that was declared and defined. Now I assign the value 42 to this variable. What is happening? Well, very simply, you have the first byte, in this case, which is the least significant one because the value is pretty low, 42, that takes the value 42, of course, in binary. So I have 101010. Okay, so the assignment is like saying, dear compiler, just set the value of the variable I just told you to the value 42. Perfect. You know these things very well, I'm sure, so we can go on. The last idea I want to give you is the one of initialization. So what is the difference between assignment and initialization? As you can see here, I've written int nb is equal to 42. Everything happens on the same line. So initialization in C is like setting the table before a meal. It ensures that the food is at its place and ready to be eaten, while assignment is like adding food to plates during the dinner. This is a good idea, right? So when you initialize a variable, like in this case, you write everything in one line. So you have the declaration of a variable, int nb, the definition of a variable, still int nb, and then you have the assignment of the value, all in one line. This is the initialization. Perfect. You understood everything, right? You do everything in one line. Now, why all this mental masturbation? Why we need to know all this stuff? Well, you will see that this is useful. Let me give you a clear example. So let's make a silly program. Vim array.c. Yeah, we are going to use arrays for the first time. Hopefully you know already what it is, but you don't really have to. So now, as usual, I include my standard input-output library, and then I just call my main function, the queen function, right? So now I'm going to create an array, and just watch what I'm doing. You don't have to understand, but it's a very simple data structure, and we will talk profoundly about arrays because it is very important in C. And in general in programming, array is a real important concept. I do char, my data type, and then I write the name of my array, which is called array, very original. And then I give the value, for example, 42. What is this 42? Well, here I'm saying, dear compiler, give me 42 bytes in memory, call this space in memory array. In every byte, there's going to be one char. Why 42 bytes? Well, because I'm reserving space for 42 chars, which are 1 byte each, right? Now I have this chunky memory, these 42 bytes. Now, what I want to do? I want to create a string. To create a string, I can do like that. Array is equal to double quotes, and then the string, for example, hello. This is a string, my friend. This is a string like the one you know very well, which is hello world, right? Like that. Now, we don't have to understand how arrays work or how string literals are made. I want just to convey you one important idea about initialization. Now, I'm just gonna print the string. So printf %s \n to go on the next line, and then I just insert array, right? You know very well how the printf works. Now I'm just gonna click the semicolon to build a command to Vim, write and quit. Boom. Now I'm going to compile my array.c, right? And then I'm going to launch with this fancy command, compilation and launch, okay? All in one line. Let's go. As you can see here, I have an error, which is array type is not assignable. Interesting. It means that I cannot assign a string to my array. Now let me do something. I delete my line number 7, dd, then I go up, v, insert, equal, and I insert here my string, hello world, okay? Now, let's try to run this time the code. I ask with ZZ, and then I just press up arrow to make the previous command, okay? And then enter. What is going to happen? Boom, it works, my friend. Nothing changed, allegedly, right? Nothing changed, allegedly. Let's watch again the program. As you can see, in this case, this time I have an initialization. As you can see, everything is done on the same line. On the contrary, when I do this, like, I first declare my array, okay? And then I do array is equal to hello world. What is that, my friend? Well, you know now. This is an assignment, right? This is not initialization. And as you can see by now, even though you don't understand arrays or strings, I guess, right? Maybe you understand already. Initialization is qualitatively different from assignment. In this case, what is happening underneath node when we initialize an array with a string? We have a string copy. There is a little algorithm underneath node that is going to copy all the chars inside the array. Okay, so long story short, initialization is different from assignment. Keep this in mind because it's going to be useful as long as you learn to code, okay? Okay, by now, I think it's enough with this declaration stuff. Of course, I'm telling you very, let's say, sophisticated things. You don't have to spend too much mental power to understand all these ideas. Just keep in mind all the details. Because in C, there is a shit ton, excuse me, the word, of details. So there's plenty of stuff like that. And as you can see, when you declare a variable, there are different kinds. You have declaration, definition, assignment, and initialization, or a thing as stupid as creating a variable, as you can see. Anyway, let's go on. So now we have this little sentence, which is an explicitly initialized automatic variable is initialized each time the function or block it is entered. The initializer must be any expression. Now you understand what is the initializer. The initializer is the value given to the variable when it is declared. Like in my array program, the initializer, now I'm going to change here. What was the initializer here, my friend? Is the string hello world, right? This is the initializer. It is initializing, it is considered an initializer because it is on the same line of the declaration, right? You understand now. So the term initializer, now it's understood. Now you have to understand automatic variable. What is an automatic variable? What does it mean to have an automatic variable? In C, we have automatic and non-automatic variables. We can also call automatic variables local variables. Just watch this silly program. I have my main function, which is the queen function, that is calling two other functions. We have the student function, and then I have the take one snack from my yeye function. Cool. So the first function gets called, which is student. Inside the function student, we have the declaration of a variable called snacks. This is an integer variable. Then we have an assignment of value 10 to the variable snack. And then we have a stupid printf. My name is Brads or blah, blah, blah. And my snacks are not globally accessible, right? When I die, they come with me automatically. This is a very silly mental hook to remember what is an automatic variable, right? Basically, automatically means that the variable is gonna die automatically with the function is called himself. So this variable snacks lives as long as the function student is alive. Other functions cannot see this variable snack. Do you agree with that? Do you understand what I'm saying? Let's just refresh your memory with the process memory layout, which is the concept you have to understand automatic variables. I hope you know pretty well by now that when you launch a program, you have a specific space in memory that gets allocated, and this space is called the process memory layout. A program launched is a process, okay? So you have a space called the stack, the heap, data, and text. Okay, cool. I hope you know by now these ideas. Your program lives in the stack, right? All the action happens in the stack. So you have in the first stack frame your main function, right? The first Tinder function that is gonna spark all your program. Perfect. The stack is upside down, so it goes from the high indexes to the bottom indexes. You can recall this by the heap that is opening up. The heap is going up, the stack is going down. Easy. Now, for ease of comprehension, I make the stack reversed. So it's easy to see what is going on. So we enter the first line of our process. Int main. Cool. I have my main function at the bottom of my stack. Now we call the student function, which is inside the main function. So boom. What happens? Well, you have a stack frame that is allocated for this function, as you can see. And inside this stack frame, you have the function block itself, the student function block. I depict a function essentially like a block because this is a really good mental model to understand what a function is a closed system that is able to communicate with other functions thanks to arguments, right? You know these ideas pretty well. So the main function can speak with the student function. In this case, there are no inputs, and the student function doesn't give back any return values. Anyway, inside the student function, you have the declaration of a variable and an assignment, the variable snack, right? And then you have a call for the printf function that here in my stupid example I have not drawn them, otherwise it would have been too long. The thing I want you to pay attention to is that, as you can see, main and the function student are very separate, right? There are two blocks which are separate. They can communicate, nonetheless they are separate. And the really core thing is that the variable snack, that in this case is this peanuts, is gonna disappear as long as the function is gonna end, right? When the function student is gonna end, when the function student is gonna reach the closing curly brace, well, poop is gonna pop from the stack, right? It is not gonna be erased. The data is gonna still be there. Nonetheless, I cannot retrieve the data which was inside the function. I cannot retrieve anymore the peanuts. That's it. That's why that variable which was inside the function was automatic, because automatically with the developing of the process, the peanuts disappear. As easy as that. Okay, now we have only the main function that is finishing, because as you can see, we reached the final curly brace. So the program is finished, the process, excuse me, has finished. And now the control goes back to the king, to the operating system. That's it for the development of a process inside your memory. Okay, I think you know this stuff. Nonetheless, it's good to repeat maybe. So here, let's reread together this line. An explicitly initialized automatic variable that you know what it is. Basically, it's a variable, you can consider it inside a function. All the variables which are inside functions are automatic. Of course, this is an oversimplification of the thing, but you need to understand practical stuff, and you can consider automatic variables the ones which are inside functions for ease of comprehension. As usual, I prompt you to dig by yourself these ideas. Here is simply saying, this automatic variable is initialized each time the function or block it is entered. Okay, very easy. So every time you call a function, for example, if you call the function student 100 times, every time you get the snack variable, the snack automatic variables that gets initialized every time. That's what this complicated sentence is saying, right? And you have just to decipher these strange words, but the idea here is easy. And then it's saying the initializer may be any expression. So it can be a variable expression, like in this case. Watch this stupid program. I have the main function. Inside the main function, I call 2 times the function foo, and I give as an input these 2 integers. The first time I get 100, 337 plus 42, right, as a result. The second time I get 92 plus 42 as a result that gets printed by the function foo. As you can see, the initializer, you know very well what it is, of the variable x inside foo, which is an automatic variable, is a variable expression. And this is legal for automatic variables. I underline this thing because you will see that this is not legal for global variables. Let's go on. Now you read, if the variable in question is not automatic, so it is not inside a function, the initialization is done once only, okay? Conceptually before the program starts executing. And the initializer must be a constant expression, essentially the opposite of before. As you can see here, we have a variable expression, 42 plus I is a variable indeed. So look here, this time I have this silly program. Int x is equal to get value, which is a function. As you can see, int x is outside every function, is per se outside, is written inside my C file, but it is not inside any function. What is this variable? Well, this, my friend, is a global variable. It means that this variable is visible by every C file which are part of the project. You can have many files, but for ease of comprehension, let's pretend we have only one file. In this case, I have this variable which is visible by all the functions of this file. Okay, it's not like the peanut which was all inside the backpack of the student, right? It was only there and only he could see the peanuts. Okay, in this case, the variable x, the global variable x, the not automatic variable x, it's visible by everyone. In this case, the book is simply telling you, hey, pay attention, you cannot initialize this variable with a variable expression. In this case, I have a function, and a function is not a constant expression, because a constant expression is an expression whose value can be computed at compile time without executing any instruction. And a function, of course, requires some calculation. So now I want you to really understand this idea of non-automatic variable, global variable, very well, in a very easy fashion. As you can see here, I have a very silly program as before with the student and the peanuts. Global, also called external variable. Now you can understand why they're called external, because they are external to functions, right? Are the variable which are globally accessible. As you can see, all the functions can see this variable. Now look at this stupid program that I made. I made a global variable which is called cafeteria snacks. Integer cafeteria snacks is equal to 100. Just pretend this value is for coffees and pizzas in a cafeteria in some university, okay? Then I have some functions and then my main function. As you can see from my main function, I have a variable student. So I have a declaration and a definition of the variable student and an assignment of the value 12. Then I print before the number of snacks in the cafeteria and after this while loop, okay? Basically, I call 12 times the function student take snack, okay? The student takes snack, what does it do? Well, it's gonna decrease the value of the global variable cafeteria snacks, okay? So the global variable is gonna decrease 12 times. Then I'm gonna call two other functions, which are professor take snack and cleaner take snack. These are two stupid functions which, as the function student take snack, are gonna decrease the variable cafeteria snacks, right? And then I just print the value of the cafeteria snacks. Cool. As you can see, all the functions can see the global variable cafeteria snacks. Indeed, this is globally accessible. All the functions have access to this variable. That's why it's called global and external, because it is external to everyone. You can perceive a function essentially like a person that can do something. Every person has its own personal things, for example, portfolio, the cell phone, personal data, ID, and so forth. These are variables which are local, which are automatic, quote unquote. They die when the person itself dies, they cease to exist. And then we have global variables which are open to everyone. It's like really a cafeteria in a university. Everyone can go to the cafeteria, everyone can change the amount stocked in the cafeteria. If a very obese person goes to the cafeteria and buys everything, there won't be any food for anyone. So everyone can influence the value of the global variable cafeteria. I hope my silly ideas are easy to grasp. So how does it happen that a global variable is accessible to everyone? Well, very simply, a global variable lives in another part of the process memory layout. These variables indeed live in the data segment, okay? So they are not participating in the dance which happens in the stack when you allocate some memory for a function that you have deallocate, then allocate again, and you have all this movement right inside the stack. These are variables that live in the data memory segment. They are going to live as long as the process is alive, as long as the process is not ended. From start to end. Hence, my friend, they are not automatic. They are not dying automatically, right? That's a non-automatic variable, a global variable. Okay, so my friend, this is the real program. As you can see here, I have my global variable. Let's try to launch it. Okay, ZZ, I'm going to compile. Boom. As you can see, the snacks in the cafeteria are initially 100 and then are 86. Cool. Here I have a very simple while loop. I haven't explained still this idea, but we'll trivial. So as you can see, the main idea is that all the functions can see the cafeteria. All the people, professors, students, cleaners, can see the cafeteria. Remember that coding is just creating models from real life. And this is a really good parallel from real life. I want the cafeteria variables to be global to everyone. And the function is a person. You have this parallel, right? So it's going to be super easy. Here on the contrary, my friend, I have the student program. I have my main function that is calling the student function. As you can see, I have my student block function that gets called. And then I have the declaration of my snacks and so forth. Let's launch this time this program. So GCC student and a.out, right? Launch. It works. My name is Ayeye and the snacks are mine. Cool. Then we're gonna change a little bit. I'm gonna just cancel x, and then I'm gonna cancel this one. And I'm gonna call a specific function, which is take one snack from Ayeye. Really bad naming, it is long, but...
Nome e cognome, come si chiama? Ayeye. Già detto? Ayeye. Ayeye.
Just to convey you the message. And then we go here, right? We go here. As you can see, this function is trying to access the snacks. Can this function access the snacks? Let's try to launch it. GCC and launch. As you can see, use of undeclared identifier snacks. Wow, the variable snacks has died. When the function student ceases to exist, the variable snack doesn't exist anymore. If I do something like that, for example, what do you think? What is going to happen now? Let's try to launch it. Boom. As you can see this time, the program has worked with no problem. Now let's try to write printf %d snacks. Okay, let's go out, compile and run. As you can see, the number is 41. The global variable 42 has been decreased by 1. This is super bad practice, as you can see. I have a global variable which has the same name as a local variable, and this is confusing, and overall is a bad practice to have global variable. You have to use them only if it is super necessary. So just look online, search on ChatGPT why global variables are not the best deal, and you will understand it's super easy to grasp this idea. The only thing I want you to grasp now is that, as you can see, the function take one snack for Ayeye is accessing now the variable snack, which exists because the snacks are in the data segment, which is always on, never dies. These snacks here live only with Ayeye, with the student. They live with him and die with him. Hence, they are automatic. The snacks are not automatic, they live forever, and namely, they live until the process is alive. I hope that you now understand this concept of automatic and non-automatic variable. So now let's reread the passages from the book, and you will see that it's fairly easy. We have just a technical sophistication to grasp. An explicitly initialized automatic variable. Initialized, you know what it means. Automatic, you know what it means. Is initialized each time for the function or block it is in is entered. Namely, every time you call the function student, the variable snack is initialized. Easy. The initializer may be any expression. As you can see, I can initialize the variable x in this case with a variable expression. That's what this sentence means. If the variable in question is not automatic, for example, it is a global variable, an external variable, external from the functions, the initialization is done once only, conceptually before the program starts executing, and the initializer must be a constant expression. Okay, now I don't want you to masturbate your mind with these ideas. It's just to explain you this little passage from the book. And as you saw, it's not terribly difficult, right? You have to understand some technical definitions like initialization and automatic, non-automatic, but the ideas are pretty simple. Personally, I never use global variables, so I suggest to you to really maybe skip these. Just keep in the back of your mind that this stuff exists, but you don't really care tremendously. One thing, on the contrary, that is really important is this one. External and static variables. This is another idea of variables you can watch on ChatGPT. This is not difficult, but we're gonna watch later. And practically speaking, practice based on code, what is a static variable, because otherwise it would be dry theory. You won't remember anything, in my opinion. Okay, so we just skip for now these ideas of static variables. So external and static variables are initialized to 0 by default. Easy. On the contrary, and this is important, you have to memorize this, or to understand. Memorization is never good, just understand. Automatic variables for which is not explicit initializer have undefined idest garbage values. So if you define a variable, declare and define, and you don't initialize or assign a value to this variable, inside these bytes, there's going to be garbage value, okay? A random value. This is very important, my friend. Let me show you practically speaking. So as usual, let's code together. Vim garbage.c. As usual, include stdio.h, int main, and then what do? I'm just gonna declare an array, so I can work with many values, because we can say that probably the value you declare is gonna have the value 0, right? Statistically speaking. But if I have, for example, 100 values in an array, probably I'm gonna have some garbage value. So I'm gonna do integer array square bracket 100, okay? And then I'm gonna do for loop for int I equals 0, I minor that's 100 plus I. Oh, printf what? I want to print the value which is inside the array in position I. Don't worry if you don't understand what is going on. Basically, I've taken a chunk of 400 bytes in memory, and I'm saying, hey, just write every byte of this memory. Okay, as you can see, there is not any initialization of these values inside the array. Okay, let's run the code. ZZ, we compile, GCC garbage, and out. Boom. As you can see, I have all my 100 values inside my array, and look at that. I have all these garbage values. You see? I haven't initialized my array with all these values. These are simply values from previous ended processes. That's it. What can I do to initialize all the values to 0? Well, I can very easily initialize my array with 0. This is an initialization of array. I'm saying, hey, please take all these values inside my array and set those values to 0. Let's launch again the program. And as you can see, now I have all zeros. So let me repeat to you what I did. I just initialized my array, and pay attention to the word initialized, that now you understand very well what it is, with values zeros. Okay, I can do this because this is an initialization. I declare, I define an array, and I initialize this array with zeros all over. Oh, right, my friend? Okay, I think you understand very well all these declaration deal, all this paragraph. As you can see, there is a lot of meat underneath it. In few lines, this book is really dense. It's like eating, you know, Gainer from the gym world. You eat Gainer with creatine and branched-chain amino acid. It's all very dense. You eat a lot of nutrients in to digest this stuff. I think it's not an easy book, but if you go through, it's golden. Okay, at the end, the book is talking about the const qualifier that you know pretty well. I already made a video about constant and I think it's so silly. So that's it, my friend, for this video. I'm gonna try to do a video minimum per week so we can go on pretty fast. As always, thank you for watching, my friend. Enjoy. Good coding.